Okay, I'm at a video. Try to see if this will work. This is the width of a normal engine. Of course, I'm set up here and I don't have my calipers. Crap. Something fell. All right, I'm back. Sorry, something fell. Tried to find it. It's too late. Don't worry about it. Okay. So what I want to show you is the width of this chassis. We're off, and we're in millimeters, and we're calibrated. Okay, here we go. The width of this chassis is 15.6, or say in round numbers 16 millimeters wide. The shaft that we're going to put in is this drive shaft. That's not even the right drive shaft. Here's a better one. Okay, this shaft, this is a drive shaft we're going to put in. Its overall length is 40 millimeters, okay? The gear that you're going to put on in the center is going to be a little over 4 millimeters, and it has to be in the center. So what I'm showing you here is how we would normally, or how I have built these little spacers so I can space the gear. And then I've built little stopper pieces where I stop the axle where I need it to so that the gear is in center, okay? So I use these little stopper pieces, then I press the shaft in until it gets to the stop point. And then I know it's in position. All right. And this is the old way. Drill this out, try to get the bushing in, and it's very messy, time-consuming, blah, blah, blah. Okay, here's the unit that I have from the late 60s that I want to mimic. See now, this axle has the gear on, right? And the spacers, so it's been spaced right, so I can remove the spacers. Okay, there it is. Then it's going to have that compliance. It can move a little bit, but watch this. I just take it out. It just... There's not, you know, what holds it in? What keeps it from falling out? Well, don't turn it around, won't fit. Okay. It won't fit the other way. At any rate, then this goes on top, you see, and it has some locking mechanisms. It has positioning points, a little divot here and a divot here, and they go into the holes that are in this cast metal piece, and there's a cutout for the gear, and the cast metal piece goes right over that. I wonder if this is like a. I wonder if this is like a. An O gauge. At any rate, there's how the axle would go. You see, this will come in flush and hold the axle in place. But now this doesn't have any bushings, right? So what we want to do is create the same idea, but with bushings. So our gear would go in here. Our shaft would come sliding across, right? And then we would press that in place with our spacers. Try it the other way, maybe it'll work better. Nope, it's tight. It's tight. It's supposed to be tight. Now I got stuff hanging on my, look at this, hanging on my magnets. Okay, so what we're going to try to do is come up with a device that can hold this in the center. Maybe still use the spacers, you know, maybe that'll work. Get the get shaft started, and then press that in. And what you want to do is you want to compress that with some kind of a stopper out here so you don't go too far. See, this one is built for this. I think that's an O gauge. This stops it right there. So if I press this in, it will hit this stop, and the gear will be centered, pretty much centered, and that's where the knurling is. Now the challenge is, we want to put bearings on this shaft. In this case, I don't think they'll fit because this is, yeah, this is already knurled. Yeah, it's already knurled. It's too big. But the idea is, now we want to put the bearings on. Here we go, like this, and then snap the bearings into a pocket that is geared for this width of this bearing. And this is the thing. It's 3. It's wider. This is 3 millimeters wide. How wide is our meat? 4.3. So you have a 0.5, 0.5, what did I say? 4.3, and we need a 3, so we got 0.6. 0.6, oh, divided by 2, 0.3 lip. Oh, crap. All right, so a 0.3 lip outside and a 0.3 lip on the inside, and then the bearing would sit down inside 0.6, and if it's 3, that's 3 points, no, 0.3. 6 and 6 is 12, plus 3 is 4.3. Got it. Okay, so that's it. Is that right? Let me measure this again. Yep, 4.2. It's tight. I could make that a little fatter to give us more meat on that lip if we wanted to. But as you can see here with this guy, this also is pretty thin as far as it's almost the same width as the bearing. There's no fat on this to leave a lip. See, this is 4 also, so that's why I mimicked it, right? Okay, won't need the 4. We'll think that through. It'll be okay. We can think that through. So the problem I had was pressing this thing in, and I have a big vise over there, and I go do it, but it's very crude and rude, and I mess up sometimes. So I had these parts. This is part 2 of this whole thing. So those are the pieces that we want to use. These are the pieces that I have just left over from a past experiment. This is a screw. I don't know what it is. It's just a screw, okay? It's nothing in it. This is a 8mm outside dimension. I can only guesstimate the inside dimension is about a 6. And look, it has a brass nut. So if we wanted to use this, and we have bearings for stabilization, I have lots of these bearings. There's a coupler for a handle. So we could do some kind of a clamping thing here where this gets clamped into something. We set it up, and then we turn the screw here, and as we turn the screw, of course, then this nut would push or pull the plate that we want to press against. So I'm guessing we'd put a plate here of some size, and we'd bring the load in on it. I don't know. That's just thinking. And the load would be mounted to this guy, so as we rotate this way, we bring it in. And we could sit here and just dial it in. And I can cut this down. It doesn't have to be this long. As you can see, all we need is to press a bearing in, like, you know, like from here to here. That's all you need. And that's like 6 inches maximum, okay? So that's the thinking. And I want it on the plate. I can do it on a 1x4 board and bolt everything down and then up, and it's manual, so there's no electronics and no limit switches, nothing like that. And I can do it with a knob. I think a knob would be fine, and just rotate this with these pieces. It'll have enough torque, enough push. If I need to, I could put a bar in it and move it, but I don't think I'll need to. And we'll press these things together in a benchtop press idea, okay, with the spacers to guide us for the dimensions, where we want the axle, how far in, how we want the gear fixed, with stoppers, so we can put this up against this stop and press the axle in from here, and it'll stop exactly where we want it, blah blah blah. And then you know the story about the wheels, because now we own this. We can print these, and I have really tough PLA carbon fiber, really tough stuff, so I can print these if I needed to in a smaller diameter. This is a factory. This is a tighter diameter. It might actually do the trick. I don't know. We'll have to see. Where'd that shaft go? Okay, here. This is a standard 3.9 or something like that. Yeah, 3.9 is the shaft we're going to use. It's been knurled but sanded down, see? So that's how the bearing fits over it. I just crudely did this, sand it down, but then the knurl, I could restore the knurl, but with a smaller hub, the knurl is actually tight and the bearing can slip over. So you could assemble this, you could take it apart. I have wheel pullers. I have a wheel puller, so I can grab the wheel and pull it off, and we can get to it. This was another device that I had, but it won't go wide enough, you see. This is a big piece of metal and 2 anvils, and you put a Allen wrench in here, and we use this for riveting, setting rivets. But you can screw this in, and it works in like that. So you could use something like this, but it's a little, not exactly what I wanted. I wanted something that's on the bench. I can pull it over, I can assemble axles, put it back, and I'm done. Now I do have a 1/4 20 with a nut. I think it's a 1/4 20, yeah, 1/4 20. I have nylon nut, so we could go something easier and simpler and just capture this nut into this guy here and run this thread in and out, and then capture this thread on both ends with clamps and whatnot with these guys, and then that could work too. But I happen to have this one. I didn't know if how much force we think we might need. I have another one, but it's left-handed thread, and I don't have any. I might have a nut for it, but I don't know if we need left-handed. I don't think so. We're not doing a machine tool here. We're just making a press, right? Okay, so that's the idea. As we assemble this thing this way, then we have all the axles in, the bearings are snapped in, and I don't think these bearings will even fit, because this was printed for the narrow bearing, you know, the one with the flare. When they made these, oh, here we go. When they made these, yeah, flare's a tough fit. Even, oh, there we go. There's the flare sticking out, okay? And these are the full flare. These are a machine down flare. The outside diameter is machined down, so this is still 8. This is 8 with 7. So with this, I had to make a notch. If I wanted to flip it around like here, I would have to make a notch. The good thing is it would just be one notch. It would be a thin notch, but it would be like that, you see? And with the notch on the inside, you have a little bit left. The bearing goes out to the wall, so you have a pretty good bit there. You could have, you know, 1/2 mil and then 2 mils on the other side, so you have a good bit. The flange may still be the way to go, but now you're going to have a flange on that side, and then when you press in the, you want to bolt on the piece. Let's just try one. Let's just see. Let's put it. This one fit in there over here. Let's put it on here. Make sure I'm holding it so you can see something. Okay. If you're looking. Now you go to put this on. Now see, it's sticking up. It would be fine if it was just the bearing, but with the flange sticking out like that, what you will have to do is machine the flange down flat on that edge, on this edge. This bearing needs to go down a little more, about 1 mil, and then you're going to flatten that flange on that side only. So then the bottom retainer of the axle and everything would fit flush, and the whole bearing would be in plastic. We don't want it sticking out. The reason I don't want it sticking out is the wheels, the hub wheels as they're made, well, he didn't do it on his, did he? But the factory ones, they have a bump on them right there. There's a bump sticking out. And so when you put those two together, you're getting really close to the maximum width we can have. So you really do need these bearings to be countersunk. In the last chassis I built, metal, I drilled a hole and then countersunk these bearings, and then I epoxied them in. My challenge was sometimes super glue would get in the bearing. It's just hard to control. You want it tight, but you don't want to glue the bearing together, right? And I had to take a few of them apart and replace the bearings. They're glued together. So the assembly process is really tough. It cannot have glue, and it's got to have a way of capturing the housing. The other thing I thought about was if I narrow this groove, make this groove go all the way down to the axle, so you have an inner and outer space that you can get in and see what's going on, and that would be easier if you're going to do either one. You can do either one. That would be a little easier if you had that gap in the axle for the assembly process. And then this is going to have to get deepened a little bit for the bearing. The bearing can't stick. The bearing house can't stick below. I mean, this one does. So this one the thing would have to be thicker to make sure the bearing outside diameter is caught, not the inner part. You don't want it jammed and sticking up like that, right? Okay, well, that's what I have. If you need any other dimensions, so let's, oh, and I had this piece left over, and this was for the drill press on the Dremel, and you could use this to bring it down. It had a spring to bring it back, but what I liked was the gear action. I mean, it's actually a ram on a, so you might be able to use that somehow. I don't know. Tooth gear, tooth rod. It's in a plastic housing. It could be a way of not having a screw, but just bringing it in as a press. Don't know. Food for thought. Quick video. I hope it's something you can at least get a little bit out of with the narration and the video, the images, and the dimensions. Let me know if you need any more. I'll try to get you some. We're going to be leaving in a few minutes. All right.